So let's move on now to the panel discussion. This will be led by our panel session moderator, Dennis Fallon, who's the Executive Director of the Utility Arborists Association. And Dennis, I'll let you take it away, introduce your panelists, and move on with your panel.
Thank you, Joe. Hey, greetings, everybody. My name is Dennis Fallon. I'm the Executive Director of the Utility Arborists Association. The Utility Arborists Association is the premier organization for individuals and companies who desire to provide professional utility arboricultural services. We have over 5,000 members in the UAA and their employers that have a commitment to the public to enhance the practice of arboriculture for the purpose of ensuring safe and reliable transmission and distribution of energy. This panel session will include professionals from organizations involved in the capture of vegetation encroachment insights via manned aircraft, unmanned aircraft, mobile mapping systems, and boots on the ground. The panel will also discuss artificial intelligence and modeling using captured data. Participants will discuss the tools they use to capture the content, also used across the various vegetation management tool sets. Today's panelists will be Larry Fox, Vice President of Marketing and Business Development with Bad Elf Incorporated. Hayden Howard, Vice President of Compass Data. Ron Chappell, CEO of Geo1. Peter Atala, founder and CEO of Voxelmaps. So each panelist will give us a brief overview to their company, how it's involved in the collection and/or analysis of data. We'll start with the collection methods and then work our way into data analytics. Following these overview presentations, I'll lead a Q&A session for the remainder of our time. Please use the Q&A function in the Zoom to submit any questions for the group. And while Larry with Bad Elf gets his camera turned on and prepares to present, I'd like to get started with a survey for the audience. We'll open up a poll question right now, and you'll be able to answer this question. We'd like to know, what is your primary goal of data collection? Thank you very much. Work management seems to be our leading goal. So Larry, with that in mind and the rest of the panelists, I'll turn it over to you and you can transition through. Thank you.
All right, well, thank you very much, Dennis. Once again, my name is Larry Fox. I am the Vice President of Marketing and Business Development for my company, Bad Elf. Bad Elf is a GNSS manufacturer and a Esri partner. We do a number of products and solutions, primarily in the world of, as was mentioned, boots on the ground, real field data collection. I happen to be a private pilot and a Part 107 pilot, so I've had quite a bit of experience in the data collection world over the last 20 years. The workflow that I'm going to talk to you about today has a lot to do with some work that we've done very closely with Forest Service, some of our customers that are telcos and electric utilities. Some of this work was originally designed specifically for pole management and forest plot management in the world of fire suppression. So I hope this is of interest to you. The topic today is using a GNSS receiver and a laser rangefinder for offset measurement. We're going to go into a little bit more detail about that as we move through the presentation. So what's this all about? This is ground-based measurement. What we've developed is a practical means to determine heights and clearances between objects in three-dimensional space. You know, for example, someone could quickly determine the precise location of a tree, the height of those trees. It's a very simple mechanism to measure fixed items such as a pole attachment or distance between two objects. So specifically, as we go through this presentation, I'm going to go over some of the topics associated with using a laser in true boots on the ground field data collection in combination with a GNSS receiver. Just for clarity's sake, I might use the word GPS and GNSS kind of interchangeably. I know there's multiple GNSS systems out there, but For the purposes of this presentation, they will be used a little interchangeably. So just to give you a little bit of a background, when it comes to accuracy, I want to start out a little bit with the traditional GNSS and what one could expect just out of the accuracy of the measurements that it's capable of doing. Most traditional GPS receivers, without any form of corrections, can get down to right around a meter at best. As you start looking at correcting that stream going to your GPS receiver, you're looking to start using some of the more advanced techniques like SBAS, satellite-based augmentation system. Very dependent upon coverage. In North America and Europe and some of the other developed nations, this is better. In certain other areas, this could be a little bit more challenging to be able to get this type of correction. So what do we do when we want to move upstream? We go to a technique called RTK, or real-time kinematics. There's two ways to really make this work. You either have to have a core station or a VRS station. Those are continuous operating reference stations or virtual reference stations that are providing corrections to your GNSS receiver. Typically, if you're less than 20 kilometers from one of these stations, you can get down to the centimeter or 2 centimeter with a highly qualified GNSS receiver. As you start moving out of that particular world, if you don't have connectivity, you end up going to a scenario such as the last two items listed here, which is either a base rover scenario or an L-band solution. So the base rover uses a fixed point receiver over a known corrected point or a point that you calculate later. If points are surveyed, you should set up over those points. The range in this particular situation is highly dependent upon the terrestrial radios used, but typically could be a couple kilometers to 10 and up to 20 kilometers. A lot depends upon radio power, environment, etc. The other solution is L-band corrections. Some GNSS receivers support L-band corrections, which is another satellite system, which tends to cover pretty much most of the whole Earth. This is very nice for areas that are extremely remote where it's impractical to get any form of correction service made available to you. The challenge with these particular scenarios and using L-band is that it can be very slow to converge on a high accuracy solution. I think the biggest element that I want to bring up being in the GNSS space is good sky visibility is important. A GNSS receiver is only as good as how many satellites it could see and how many it could see clearly, especially those that are well above the horizon. So why do we want to use this particular technique? From a practical point of view, laser offset measurement provides a means to capture large areas without the need for something like a total station. You don't need to necessarily traverse to a new location to make new measurements, which is really, really handy. In the real world, 400 to 500 meters from your target is actually very, very practical. And there are options to extend that range, but generally below a kilometer is very reasonable. So I guess the question is, what problem does that solve? Restricted areas, such as metros, may prevent direct access given property, private property, or hazard considerations. All one needs to do is set up a receiver to acquire a good position. So we set up the GNSS receiver in an environment where it's not obstructed. And then each point captured only takes a few seconds plus whatever it takes to annotate that point. So if you're using something like an app to describe the features of what you're collecting, that's really actually going to take the lion's share of the time. Because GPS receivers don't work well in canopy and in urban canyons, you think metro areas, for example, the GPS receiver actually can be placed in an unobstructed location, and its position is offset using the laser distance measurement. The cost for a terrestrial-based solution, such as this method, is far less than that of the cost of using something like a total station to capture all your data. One big element of this technique is safety. We're a big proponent of safety, and using a laser rangefinder and a GPS prevents the need to access challenging environments. It allows one to set up in a safe location for measurement. So you can imagine taking measurements next to a busy road or near a steep grade or near an area that might require restricted access or other forms of protective body coverings just to even enter. So this technique really allows you to translate real-world spatial locations without having to actually be present at that location. So what do you need to actually do this? Well, it's our suggestion that you have a highly accurate GNSS receiver. And what that does is create a low ambiguity in the relative position you're locating from. And what I really mean by that is we start out with a good location. So when we're offsetting that location, we have a good representation where that offset location is, because the high accuracy GNSS receiver is providing us, down to a centimeter level. So its cumulative error is only then the error of the GPS plus the error of the laser rangefinder. Speaking of laser rangefinders, we work with a company called LTI or LaserTech. They have a True Pulse series, which was shown in the previous picture. It provides accuracies that are easily at the sub-foot level. Ideally, though, we suggest that you use a laser with a compass, as this speeds up the workflow dramatically. As was mentioned in one of the previous talks, if one's collecting attribute data, something like Esri's field maps provides an integrated solution that can operate on a phone or a tablet and record not only the offset location, but the attributes of all the locations. In this particular scenario, with our receivers and an LTI rangefinder, you have a direct form of integration that actually creates a really nice workflow in collecting those offset measurements and heights, such as pole attachments or tops of trees or lines. I will mention this, that standalone options are viable. You could do this all just simply with a laser and a GNSS receiver, but I would suggest that an application provides a richer reporting experience. So just to kind of give a brief synopsis of what we were talking about in this presentation, this particular technique, the grounds or the boots on the ground technique, is really viable for small areas and local collection, and really an ideal use case for those particular scenarios. As I mentioned, in some remote areas, correction methods may be inaccessible and do require more sophisticated techniques. That's where we talked about using L-band or base rover type corrections if you really want that highly accurate GNSS location, so your offsets are spatially correct. The one nice thing about this is with data connectivity, the information you're pushing back and forth through your app can be seen in the back office almost immediately. And the nice thing about that is you have staff on site. This allows you an opportunity to collect the additional features while staff is in the field if the folks in the back office need additional information. We've seen in our own experience that one of the most expensive areas of boots on the ground collection is getting those people out into the field, and having this bidirectional means of collecting data is really fruitful and saves a lot of time and cost. Training for this technique is actually generally less than a day. It is actually very easy to train your staff in how to become effective data collectors and use the equipment in a way that's reliable and repeatable. And finally, this is very cost effective. The price of a laser and a GNSS receiver is not prohibitive and gives you the ability to rapidly collect field data and achieve really good spatial results and collect the information you might need to do vegetation management. So a lot of information presented there, but if you have any questions, my email address is right there. We'd love to chat with you more and talk about the options that we've learned and how laser offset data collection could apply to your particular scenario. I'd like to thank you all.
Thank you, Larry. We'll transition over to Hayden.
Okay, thank you. All right, well, thanks for the time today. Very interesting presentation, Larry. Thanks for that. I'll just jump right in here, try to keep to my 10 minutes. So I'll give a quick company overview, talk about some capture platforms, mostly on the UAS drone and backpack side of things, and then go through a typical project workflow, the planning, deploying, capture, process, and verify. We do have some platform and extraction information, but I'm going to leave that to other folks that are speaking today, maybe answer some questions during the panel. So a little bit about Compass. We have several Compass family of companies. We've been around for 30 years. We're based in Denver, Colorado. We have Compass Data, which really started with a survey of ground control points back in the 90s. Been to over 100 countries around the globe. In doing that, where geodetic expertise is really where we lie, and accuracy is really important to us. We have Compass Drone, which is basically supporting entities that want to set up a complete drone program. So we do Part 107 training, we sell hardware, software, and we also do services. Then we have Compass Com, which is a vehicle tracking mobile resource management software company. And I'm in charge of Compass Data and Compass Drone. So I guess another interesting thing about Compass Data is we're ISO certified, we have the FAA certification, and we're a woman-owned small business. So as far as our core capabilities, coming from a survey company and doing ground control, which we still do a lot of today, we've had the opportunity to work with satellite, aerial, drone, mobile, bunch of different partners over the years. And that's really how we approach any project that we do. And it's still relevant for transmission distribution and veg encroachment, where we look at the different platforms, the different technologies, and we use the right tool for the job, basically. So for the capture platforms, primarily we're using vehicle, backpack, or drone. For today, I'll really stick to the backpack and drone side and logistics around that. We're using really these technologies, use GPS, IMU, optical imagery, LiDAR. And this area over here on the right is basically the pieces of equipment that we're operating today. So from Obtech to Regal to Trimble to Leica, and then on the airframe side, FreeFly, Alta, and DJI are primary platforms. So in deciding what platform to consider, we really look at the end goal of the division or different divisions within a utility company, and say, okay, what are they trying to do? What's the end goal? It's really important to us to figure that out at the front end. So are they just looking for XYZ locations of their poles to get an inventory where they already have pole information, but it's not accurately spatially located? You know, we might use a different technology than if we need to get strike tree information and sag line and all that other detail. But basically, when the requirements get heavier, you know, that's when we do more survey control and checkpoints. And then we use different technology to get densified data, because the more dense the data is, the more detail you can extract from it. So now I'll go through really just kind of a general workflow approach that we've used in the past, and I'll kind of stick to the plan, capture, process data, publish. And the publish, extract, delivery, I'll kind of leave out and can answer questions later if there's time or there's interest. So this is kind of an example of where we were working as a sub in the prime. A good partner of ours was doing the mobile mapping. And basically what we do is we get the circuit data from the customer and we put it into typically an Esri platform. And then we do some buffering to say, okay, what's the distance from the main roads? Does it fall within 100 meters? If so, then we believe it will be captured by a vehicle. And then everything outside of that, we consider it off-road, right? Which is the backpack or the drone. And from there, we look at the level of difficulty, which I'll explain here in a second. And then we can approach the project appropriately and get a good timeline or estimate of how long it'll take and the effort it will take. So for going a little bit deeper on that, so for doing the level of difficulty assessment that we do before we go to the field as part of the planning process, we look at these, what we will consider off-road segments, right? And then we run our algorithm that we created that takes into account things like the number of parcels that you'll be going through to capture a section, the segment length itself, nearest to the next segment, distance from the road, elevation change between the start and the end of the point, and it gives us an idea of what we're walking into, right? Is it going to be an easy 5-mile stretch that's really flat and goes through one ranch? Or are we going to be going up and down mountains, going through a bunch of different parcels, and which really opens you up to a lot of other dangers with dogs, grow sites, unhappy landowners, that kind of stuff, even if you do some pre-call to let people know you're coming beforehand. This is definitely not perfect to say, okay, this is how we plan it, and this is actually the reality of it, but it definitely gives us a good understanding of what we're going into, and we found it to be very helpful. So after the planning process, that's when we deploy. So this is kind of a quick view of how we look at the deployment. So for this case, where we're working with a partner, they have the vehicle, which requires one person. And then for us, we're looking at 2 backpacks with a 5-man crew, and everybody's got radios for safety. 2 people walk together. And the reason for the 5th person is really somebody to drive and make sure that they can basically run shuttle and get people back to the starting points and be as efficient as possible. And then also to swap out the driver from day to day to day, because you're doing a lot of walking, a lot of hiking, and it can be exhausting. So it's good to kind of have that 5-man crew. That's what we figured out works best for our crews. So, and then typically what we do is we go out, we do the areas that we think are backpackable, and then we have an app that we've created that basically has a dashboard that says, okay, what's the % complete? What hazards are there? Is there somebody that says you can't go in there, which is fine. At that point, you just mark it, take a photo if they'll allow you to do so, and then it uploads automatically. The other thing we're using that for is to, get to a location, and let's say it's really, really steep, nasty downhill, uphill, and the backpack crews can mark it and say, hey, this would be more appropriate for the drone to come back and to map it, or a really long stretch where airspace isn't a problem. And the other thing that we're doing, as I had mentioned earlier, with really any of our projects, is we're serving a ton of control and checkpoints. Even when it's not really required, that's just where we come from. It's in our DNA, so that's our approach. And it just gives us confidence and customer confidence in the absolute accuracy of the data. So from there, data gets uploaded, and then it comes back to the headquarters here in Colorado. And then we start doing the calibration, the post-processing, taking into account the datum and epic requirements, which is sometimes something that the customer knows right off the top of their head, and other times we kind of got to work with them together to explain what it is and guide them to what we suggest is the best way to process and datum and epic and coordinate system for their specific project. Then we take the spherical imagery and process it, do the positional accuracy deviation results. So that's what you're seeing here is this report, which is our compass accuracy analyst and compass topo analyst. And basically you're taking checkpoints and you're understanding what the horizontal and vertical errors are of the data to make sure that it meets the requirements, whatever those requirements may be. And so just a quick review. It's a lot to cover in 10 minutes, pretty fast, so happy to answer questions. But a lot of our time goes into the planning side of things. It's critical from my experience and from sending guys out to the field to do this kind of work. The more time and the smarter you can get about planning, the more accurate you can get about the timeline it takes, identifying what system you're going to use, and going out to the field and capturing it. So with that, I'll stick to my 10 minutes and look forward to the panel discussion. And thank you all for your time.
Thank you, Hayden. Next, we'll hear from Ron with GO1.
Great. Thank you very much, Dennis, and pleased to join this group. Let me hit share. And GO1 is a airborne analytics LiDAR firm. We specialize in corridor work. We're based at the Hawthorne Airport, just a few miles from LAX and across the runway from Tesla and SpaceX. Perfectly positioned to really do work anywhere in the world. We can jump on a flight just in a few minutes. We're very much results focused. Our scanners, we have several different Regal and phase 1 configurations are set up based on the task at hand. At this point, all of our work is on full-size helicopter. I think Dennis maybe shared that 60% of infrastructure, electric infrastructure, is off-road. We can be incredibly efficient, with a helicopter. Mobilize, at 100 miles an hour to a location, pick that data up, and be on to the next airport. Also, very much about what does the client need in terms of analytics. We're seeing a color infrared 4-band image, and then making sure that that data is very accessible to the client and actionable. Probably a screen that everyone has very familiar with, but just the very basics of LiDAR. We're sending out pulses at up to 600,000 per second, even more depending on the scanner. Always using a very high-end IMU, in this case a Planix AV610, to calculate that pitch, roll, and yaw. And we always put our GPS antenna on the tail of the helicopter. That is to do two things, really, to get it at the highest point and above the rotor disc, and also when the helicopter might have is banking in a turn, it's the area where we're least likely to experience a cycle slip. Our post-processing is always to ensure that XYZ absolute accuracy using control points, and then also different software to assure that if you have multiple passes over an area, that data aligns perfectly. In this case, where my cursor is, the red, yellow, and green represent 3 different passes, and you want those LiDAR points to always show up in exactly the right place, so that you are not showing 2 lines when you really only have 1. Getting into risk mitigation, so many uses for LiDAR data. Once you have that good data, you can do so many things with it. Oftentimes, our projects start out with, where is our pole? In this example, the utility provided red dots. This is where they believe the pole to be. Not necessarily their fault. It could have been collected GPS 20 years ago or 15 years ago when it was first put in and never updated. So our crews visually fly the corridor. And then our first step is always to correct that network and come up with the actual pole locations. We estimate that once you have accurate pole locations, subsequent costs for acquisition can go down 30 to 35% because you're no longer having to look for where the actual corridor is or to go to the effort of geolocating the poles. In the veg encroachment, we deliver up to 9 different analysis. We have first of all a P1 that is determined oftentimes by the CPUC for a high risk, and then we have up to 4 different categories for a grow-in risk or 4 categories for a fall-in risk. The important part is that, again, we want that data to be incredibly usable. So we will decimate that information. Instead of showing every point of a tree that is in violation, we will take that data and condense it down to 1 point every 10 feet for easy use in the field on applications such as Fulcrum. We're also increasingly being asked to do tree counts and biomass analytics. In this case, really, we just have 3 classes. We've isolated it to the bare earth layer, the high veg layer, and then interestingly, a low veg class, which sometimes is thrown out, but it becomes we have low level grasses that are under, say, a half a meter. These can be very combustible depending on the climate at the time, and may be very valuable to know what is in that corridor. Also with the intensity of data that we're collecting, which is now a minimum of 50 or 60 points, up to 100 plus, we have data to be able to do a DBH measurement to enable that further analysis. Also, as part of that, doing automated tree counts and then making it simple to understand. In the samples that you see here, just a nadir view, we've dropped in the different polygons and the model of that line, just a very basic method 1, and then seeing where those trees are and arbitrary tree names. And then following that same line of making that data accessible, we've come up with our own tree viewer. So we take the data, drop it into a Python script and visualizer tool. We can see where the trees are. We can filter by tree species. We can filter by the location or the name of the circuit, and then see a histogram of the vegetation height within any selected area. And then in the lower right, we have a table which can be exported that has the arbitrary veg ID name and the lat, basically the XYZ of the base of that tree, as well as the average spread of that tree. So very much about visualization, making it easy for anyone to see. Another version of that, in this case, using that same LiDAR data that was originally captured for vegetation, we created a DEM, and then we calculated the pole lean and put those up against each other so that now we can see where poles might be leaning. Is there any correlation between the elevation they're at, or if they're in a valley or on the top, for how the pole integrity might be affected. Another benefit of the LiDAR data, and this is where if you collect a great LiDAR data set, it can be used by multiple teams within the company. So while we start out with perhaps on a project with the vegetation division as the original stakeholder. Engineering or roads or substations can all use that same data. In this case, we use that LiDAR data that was originally used for veg to do clash detection. So we have detected the closest distance between any two conductors in a span, and we also have the XYZ coordinates of every attachment point. And for me, this is probably the most important screen. It's to realize that sequential data increases the value of the original data. If we scan, create LiDAR and analysis today, it's a point in time. Next year, it's a comparison. But that third time we collect and analyze that data, we can now start to create trend lines. That moves us from a calendar-based, say, vegetation mitigation program to a predictive schedule. And thanks very much. I hope I haven't gone over my 10 minutes here, Ann.
Right on the numbers. Thank you, Ron. So then we'll Peter Atala with Voxelmaps be our last presenter before we move on to the panel discussion.
Hi, Dennis. Thank you so much. Hi, everybody. It's great to be here today and have the opportunity to tell you a little bit about what we're doing. Some really great presentation already from everybody, and really like what's being done in terms of the collection. We're going to focus a little bit on the analytics and what we actually do with the data afterwards as well. So I kind of want to introduce you to kind of what we do using 4D voxels, which I'll explain what those mean. So very quickly, in terms of the background of our company, we've been around for about 5 years. We were a spin out from another mapping company that was based actually in Europe, but we set up in San Francisco. That's where our head office is. We now have 6 offices around the world. We're approaching 400 people, and we do a lot of data collection and data processing. So at the moment, per year, we're collecting about 1.3 million miles of data. So it's fairly substantial already. But everything we do in the company is really around this concept of building maps for machines. So I just want to take a moment to explain the difference between a human map and a machine map. So human maps, obviously, we all know that's what's on our phones, in our cars, what we use on our computers. And really, they're around 2 use cases. The first being navigating somebody to a building or an address or a position. The second is a visualization layer of geodata. And the majority of human map data is 2D, and it's relatively low resolution, 1 to 3 meters in terms of accuracy. If we now look at machine maps, these are very different. So we're really talking about 3D and 4D volumetric models, and I'll explain what I mean by that. But looking at these kind of models, we're analyzing everything, not just big objects, but all infrastructure, telecoms, utilities, vegetation, even land structures and land classifications. And we're doing this at very high resolution. So 1 to 4 centimeters is typically what we do. And at that kind of resolution, it's not just about the location and recognition of an object, it's also about the measurements, the attributes, all of the sub-features as well, which are really important. So when we talk about machines, we mean everything from computer models and artificial intelligence to better understand environments or given areas, all the way through to actually forms of autonomy, things like autonomous cars, drones, even things like delivery robots as well. And the requirement for this data is to be everywhere. So the biggest use case at the moment is outdoor, but we also are looking at indoor models, even subterranean and ocean data as well. So I want to explain what I mean by volumetric data in comparison to just standard 3D data. So this is an example of a 3D map from Google. And this is from Google, but you can have it from Apple, from here, there's lots of different providers. And this is a really great tool. It's a great human visualization tool. It looks very pretty. It really is 3D. But when we zoom in, we see it's a very low resolution structure. So for visualization, this is absolutely fine. If we want to perform measurements, then this is not very useful. And that's because we're using very low resolution meshes to create this kind of technology. There's no interior information, and you can't do incremental updates of the data. So what we're trying to do here, what we've really implemented is a different approach to 3D. So using a volumetric data set, so that uses voxels, which I'll explain, this allows us to map the surface information, but also interior information. And it allows us to do incremental updates to the data in real time and create a truly 4D data set, just meaning that you have a time dimension now. So it's not just 3D. Actually, to Ron's point, you can start to actually look at the trends, not just what's there currently. So the way that we do this is using voxels. And voxels aren't new. They've been around for a little while now. But a voxel is a 3D pixel. It's just a cube, essentially. And so voxels have been used in computer games. They've also been used in things like brain scans, and they've also been used in robotics. And actually, we took a technique from robotics and we applied it to mapping the entire planet. So the technology is called an MRVOG, or a multi-resolutional voxel occupancy grid. So essentially, we took the planet and we placed a giant megavoxel over the top of the planet. This megavoxel is then full of multi-resolutional voxels. Now, theoretically, they can be absolutely any size, but typically we use 1 centimeter voxels up to 8 meter voxels. And each one of these voxels occupies a permanent position in space and has a unique address. And the model goes through everything. It goes straight through the planets, all through the buildings, through the oceans. It's everywhere. But it's blank. To start with, it's just a 3D georeferencing system. So what we do is we validate the occupancy status of the voxel. And we do this using LiDAR primarily. So if the laser beam from the LiDAR passes through a voxel and it's not reflected off anything, we label this as free space. But the moment that the laser reflects off a surface, we collapse down to the smallest unit of the voxel, currently 1 centimeter, and we label this as occupied. So what we're doing is we're etching out the matter of the planet. But really at the core, what this is a global spatial database for 3D and 4D data. So all of the reality capture data, all the point clouds that you guys are collecting, this is the perfect home to really make full use of it, not just for an initial modeling, but for long-term modeling as well. And we've designed this to be persistent, meaning it's always there, it's always on, it's always accessible, to be real-time. So if you even had real-time data feeds, it can take that. And really to be planetary scale. So it's designed to handle thousands of petabytes in terms of scale. But it's not just about the voxels. In this particular VOG configuration, it can do some pretty smart things. So firstly, each voxel is a measurement unit. So it's very easy to perform calculations in 3D. Then on the surface of the voxels, we can layer additional information. So typically these are colors. So this can be from RGB cameras, but it can also be from hyperspectral. We've even done things like radar. So the voxels give an aspect of the shape, the surface information gives color, and then we apply machine learning and artificial intelligence to recognize what these voxels actually are. And it does this fully in 3D. It's not a 2D semantic segmentation. It's really a 3D voxel-based model. But it's not just 3D. Every single voxel in the model has an infinite number of time states. So we have this temporal data component. So that means that the AI can work on what's already there, what's currently there. But also if you have sequential data, we can look and compare what's been there in the past as well. And then you can do very sophisticated change detection. So when you build all this together with the permanent addressing, with all these kind of features, it becomes a very powerful platform for building out true digital twins that can grow 4D digital twins. So this is an example. This is using occupancy alone. Then we layer on the surface information onto the voxels. And then the AI is now doing the automatic recognition and classification. And then at that point, we can have complete control over the data. So we can remove things that we don't want. We can export them out into different data formats. We can connect them live via APIs into other systems as well. So it becomes a really powerful tool. So that's the concept in general, but I really want to focus down now on a little bit about what we're doing in terms of utility and power lines. So essentially, we can take point cloud data, so LiDAR data plus imagery. It doesn't matter how it's been collected, whether it's aerial collection, mobile or backpack collection, and we create this 4D digital twin. All the data is kept live and persistent and always accessible through a number of channels, whether that's web or desktop or on premises or even mobile applications. And we can allow for incremental updates to that data. Once the data is in that format, then the machine learning and the AI can do a bunch of different analysis, which is really helpful. So everything from the power line recognition and classification, the key measurements around power lines, the sag sway analysis, the vegetation analysis, things like the grow-in, the fall-in risk, notice zones, and even some of the risk analysis around vegetation management from NERC as well. So giving some examples of this, we've done quite extensive projects, a lot in California at the moment, actually. This is one example of it. So this is kind of zoomed out and looking at the data. All these different colors is the AI recognizing the different features and automatically classifying them as well. And then specifically on the vegetation management for a customer, we actually looked, in detail at this about providing tools which are really helpful for them. So really getting into that data and analyzing where the problems were, where we really have issues and notice areas and overgrowth, calculating the volumes, which can relate to the amount of time it will take and the resources it will take to clear it out as well. But going a step further as well about doing predictive grow-in models. So not just where the vegetation is at the moment, where it's likely to be, and predicting that using deep learning techniques and providing a view of that as well, which can be used then in the maintenance of it as well. We've also done projects where we've really looked in detail at forests. And so even things like tree trunk reconstruction. So even where the LiDAR hasn't got enough density to say exactly, for example, where the center of a tree is or where the tree trunk is, that can be reconstructed with AI. And then you can do some very sophisticated fall-in analysis as well. So I just want to show an example of this. This is a project we did for an organization, a nonprofit called the Earth Archive. And we worked with Geo1 and Ron. They did an amazing job for collecting the data on this. So I just want to show you what this looks like. So again, all of the data was collected with LiDAR. This was then put into the system, voxelized. You have full control. It created the digital surface models, the elevation models, represents all of the trees. You can explore all of this, reconstructed the tree trunks, performed calculations on them as well, relating to the trees themselves, but also in terms of the infrastructure around as well. So it's a really powerful technique to start to think about using voxels as an approach, rather than just keep the data as LiDAR points and process them and then archive them off. Putting them into a model like this really allows you to start to bring predictive modeling to this and start looking at what the 4D data sets look like. So that's my presentation. Very happy to answer any questions. Thank you.
Thank you, Peter. And the whole group appreciate that those presentations in there. I'll invite the entire group to turn their cameras back on so we can go into the Q&A session. And while we're doing that, I'd like to hit the audience with one more poll question, or at least one more poll question. So we'll open up that poll here. And what method of data capture are you currently using for your inventory? We'll give that a minute to run. While that poll is running, maybe I'll tee us off here a little bit on a couple of questions. We've had a couple come in. Some are individual, and we'll maybe come back to some of those individual ones in a moment. One of the questions that did come in that I think is maybe the whole group can speak to a little bit. There's a question, it was specifically laid out to Hayden, but I think it's appropriate for everybody. What's the turnaround on post-processing? How long does it take to go from data acquisition to a usable product information in the field?
Yeah, I guess I can start that off. So for the backpack and the drone side, it's really, I'd say 4 to 6 days from day of capture, right? And we kind of try to operationalize this with our customer where when we were mixing the mobile with the backpack and the drone, where we would look at a circuit, we'd be able to go out, capture everything, and turn it around in 25 days. The idea with that was that they could go and do the tree clearing, and then we would go back out and make sure that it was actually done. But that customer really couldn't operationalize it on their side like we all had hoped at the time. But yeah, so for a circuit, We were doing 25 days on the individual day of collection. It was 4 to 6 days for backpack and drone.
Thank you. Our first poll, one of the questions, the first poll asked, was what's the primary goal for data collection? And work planning came out very heavily. Pre-planning came in after that. And then hazard tree analysis or awareness felt down by then fuels and post-work auditing. Forest fire, wildfire fuels, and post-work auditing, I find that of interest. What comments would you have around that from the audience perspective? Do you have other areas? Is that consistent with your other customers that are out there? Or is that a market that, is this audience poll different than what you observe from other areas?
Is that question to all of us, or?
I think I'll throw it out to the whole team. Yep.
So I can go first on this. So I think it does depend on where we're doing the actual collection. A lot of it is around the work effort. So there's a lot of getting to grips with how much vegetation there is out there and what it's going to take in terms of resources to do it. But then certain areas where there are more extreme risks in terms of fire, you see those priorities kind of shift a little bit. It kind of depends where they are.
Oh, thank you, Peter. Appreciate that.
Shall I go ahead and share the poll number 2 results?
That'd be perfect. Yeah, thank you. All right. So visual grace and LiDAR and aerial imagery. Perfect. I'm going to capture that quick in so I don't have to ask you for it a second time. Thank you. All right. Ron mentioned this while he was talking, and I'll approach with maybe Hayden and Larry have some comments on that. With over half the infrastructure, energy infrastructure, being off-road, does that add any complexities to your operations? And what strategies have you used in the past to help overcome some of those?
I think I could start with that one, Dennis. I think most of our data collection tends to be off-road, at least where we work with folks or in pretty remote areas. I think about some of the work that we've done in the northern part of Arizona. That's way off-road. We find that the techniques that I was talking about, as I mentioned, were originally designed for forest management, primarily for just fire suppression and tree health. But we discovered along the way that that became really applicable to a number of other industries. So I think all the workflow that we've designed has been meant for either operating in remote areas, potentially with or without coverage, and each one of them are viable.
All right, thanks.
I guess I can comment on that as seen if Ron wanted to, but I think key is to make sure that you're looking at all the available technologies out there, right? Working with partners and making sure that you use the right tool, right? So if it's really remote, the strategy might be to just do all aerial, right? And do it in such a way that the control that is needed can be captured easily without having to go out to these remote areas. So you basically do a big old voxel and block it out in terms of square kilometers, square miles or something, as opposed to really focusing just on the line. I've seen that done because the increased cost and aerial acquisition might be less than the cost to go out and survey in really remote areas. So that's one approach.
I appreciate that. Our data, the poll we just had came back with visual ground-based inspection, overwhelming with 45% of the respondents said that that's their primary data collection process. Now, Ron, maybe speak to that a little bit. What's your perception from an aerial-based data collection? Where is it a cost factor you think that drives that? Is it a integration of the technology and the data capture that's driving that? Do you have any thoughts around that? I'll start with you, and maybe the whole group can kind of speak to what maybe drives that our audience is predominantly using ground-based now, thinking about that in perspective that not necessarily all of our assets are vehicle accessible.
No, sure. Thank you, Dennis. I think to echo what Hayden said, it's the right tool for the job and what needs to be accomplished. Where helicopters are incredibly efficient to fly, maybe 100+ miles a day, of acquisition. It may take us 2 or 3 weeks to deliver that data, where a ground inspection, the data is essentially delivered at the moment it's collected. Although you may not, it's, I think I saw a statistic of up to 16 miles a day. So it's, what is the delivery cycle? Where is the location? How do we get the information that's needed? On the other hand, a ground crew may not be able to see everything because they're the forest for the trees, where the LiDAR data can be used as an absolute reference for years to come of what was there of everything, not only within the corridor, but on the outside of the corridor as well. Just an example, last week we were doing a collection in the Southern California area, and in one day we were in 3 different states. They left at 8 or 9 in the morning and they were back at 5 in the afternoon and covered, I think, close to 200 miles of transmission.
I think just to add to that as well, Ron, I think, when you're looking at the visual inspection versus LiDAR, I think what we see anyway, there's a big increase in LiDAR. Again, totally echo the point in terms of the right tool for the right job. But also we do see a correlation in terms of internal teams within the organizations as to how efficient they are at actually dealing with the LiDAR data. So LiDAR data is incredible, but it's actually kind of difficult to process. You can obviously outsource a lot of that. And then you get these very big kind of silos of information as well. So that can be one of the things that sometimes hinders or just slows down some of the adoption of that in certain organizations.
Yeah, I would agree. The opportunity, Peter, is what you're doing, which is to take that data and make it accessible, to analyze it any number of different ways and then make it accessible to the end user.
Yeah.
I guess I can comment on that too. I think the more, depending on what kind of customer you have and how many divisions they have, the more you can get into these different divisions that have different use cases for it, the more you can deliver from aerial down to the ground, right? Because if you're working with one division that they just want to know the correct locations of the pole, they don't need it ground-based, right? But maybe the engineering or the survey group does need that for pole loading or understanding what every little bolt looks like, right? So as long as you know what division you're working with, you can offer them the right solution, and ideally you can go to the other divisions and show them the overall value of the data and get more and more people using it.
I would have to concur. I mean, the LiDAR solutions and some of the aerial solutions really cover vast amounts of area. And, there's definitely value for the boots on the ground, especially if you're looking to, do a verification. Did something occur? But as I mentioned in my discussion, I mean, one of the most expensive uses is sending people out into the field. So if you're going to put boots on the ground, there should be some high value to that because that is an expensive use of resource. Can be very valuable. You could do quite a bit of localized inspection with the people in the field, and sometimes because of the scenarios and the topography and all the other things that they might be measuring, there's ancillary benefit to having a person there. But with anything, with any tool or technology, you have to be really thinking about what is it I'm trying to assess while I'm putting that person there versus can I do this with a remote technique that would provide me a lot more information.
Yeah, Larry, I totally agree on the the boots on the ground for the verification. I think there is still a slight, I don't want to call it maybe trust factor or comfort level in using remote sensing and the new technology and the analytics because we have years and years of history of an experienced person in the field looking at the particular issue. And we can ask that person questions where, as opposed to delivering tons and tons of information in a new way, we've got to close that gap between the comfort level for that experienced person on the ground versus this new way of delivering data.
I appreciate perspectives on that. One of the things I heard in there talking about different division and different needs based on inspection. Inspection is a lot of things, right? Whether we're focusing on veg in this discussion, we talked about pole loading, talked about some nuts and bolts. You talked about some other assets that are out there as well in these corridors that utilities have interest in. And obviously we talked about costs and impacts. So if there's multiple opportunities in a single pass to gain pieces of information for different areas, that's always a benefit. Would you say that there is one silver bullet of inspection out there that utilities should be hanging their hat on, or are we really still in a position in the utility sector that we need multiple layers depending on need?
Maybe I can go for that. I think again, it's multiple collections, but what I would say, the advantage to have a base map from LiDAR is invaluable for the future, right? So really kind of creating that kind of true ground truth, right? That in 3D versus just doing some of the other techniques. A lot of that data can then be related back to it. So it can be a bigger investment, but we definitely see that a lot of the utilities and the customers that we're talking to really see that benefit for the long term, not just immediately what's required, but what does this look like in the future? How can we relate it back? I don't know, Hayden, if you might agree with that or what you've seen with some of your customers.
Yeah, no, I absolutely agree with that. And I think it's just more exposure to the data, to different divisions, and then operationalizing it. Like I had mentioned earlier, we had grand plans with the customer to really operationalize per circuit and return and remap, and it just wasn't possible on their end yet. As you can imagine with the big utility companies, sometimes it's hard to move fast and maybe it's almost there, but somebody retires or whatever it is. But I think the LiDAR as the base is critical, and then getting buy-in from different people is just going to take time for the other aspects of the use of the data and operationalizing it gets adopted and spread widely through these different divisions. I mean, I've been backpack mapping before where somebody did clear a bunch of trees and it was sitting right underneath the line, just as fuel, because it was too steep. They didn't go back and clean it out, which is, I think would be of interest if I was operating, a distribution network. And I think if you can go back and recapture, and then that becomes part of, some action that's taken, I don't know, that's a division that could really use that information.
Dennis, you actually brought up a hot topic that's existed in all of these particular scenarios, which is a lot of this has to do with information sharing. So for example, the pole loading concept that you mentioned, sometimes there isn't information sharing between, telcos and utilities, and I'm sure I could open up a really hot topic about that discussion, but the reality is there's a lot of information that's collected, but the visibility actually is probably a bigger topic because somebody's paying to do this collection, and if one utility or one interested party doesn't have access to that information, it's only as good as who happens to possess the data. So I mean, I know there are initiatives in my state to start doing some more data sharing of all these layers as they're collected, so that at least there's some potential mutual benefit that comes along with that. There's the safety side of the fence, which is, hey, there are assets out there that could be at risk. But as people are doing things like pole loading, one of the biggest challenges we've seen is the permitting process. You can go get a permit and go put something on a pole while somebody is also permitting that pole and trying to put their own asset in there, and it's kind of a who gets there first wins. So in the grand scheme of things, we have access to a lot of information, but I would suggest a big topic should be, hey, how do we share that information, or at least share portions of that information, so we're not doing this N times over.
Thanks, Larry. Appreciate that perspective. And I'm gonna do two things at once if I can. If you could put up, we loaded up a third question, poll question, and that dates back to a question that came out during Chris Kelly's conversation. I think it's relevant for this group as well. If you could put that poll up about data capture frequency from LiDAR frequency, I'd be interested in the audience's thoughts there. And while that question is being asked, Larry mentioned a little bit about information sharing and the importance of information sharing. And one of the things about information sharing, I think about it at a fundamental level, really is to be able to translate that information into your needs. And how does that relate, and what are those relations in there? He also mentioned permitting. So I guess I've got a question for the entire group. Is there any regulatory oversight around how data is captured and modeled now? And if so or not, what are some of the opportunities and challenges, along with some regulatory consistency or compliance with data analytics?
Dennis, I can take first crack at that. On our side, with many of our clients, we need to go through a cybersecurity review just to get as part of the master services agreement, and then we have to document that any data that we're working on is based or housed on US servers, and that information typically is delivered not via hard drive, but via an online methodology, sometimes directly to the client's own servers. That's on the data side. As far as the collection side, depending where you are, for the most part, we have to go by any FAA regulations for flight into, say, we're flying 500, 600 feet off the ground. So we need clearance from whether it's if a line happens to go through a national monument or national forest, we need permissions, or a military area over tribal land. So there are a lot of other pieces of the regulatory puzzle that we need to be very aware of. And those are either, because there is a law associated with it, or if it's just a fly neighborly approach, so that people know we're there and what we're doing.
Dennis, are you also talking about kind of the requirements about how the analytics are done on the data itself, or?
Yeah, it was a little open-ended, but sure, I'd love to hear a little bit more about that as well.
Yeah, so I mean, a lot of that we find that the utilities themselves will do some of that analysis, and so they will have a specification. some of that, around the standards, the risk assessment standards from NERC, for example, the different, requirements levels, depending on whether they're transmission lines above 200 kilovolts, et cetera, or distribution. Obviously, there's kind of less regulation around it as well. So there are some standards which are to be adhered to, and we try and help automate that, although we're not necessarily responsible. That's still with the utility company, but we try and automate the calculations as best as possible to, if we can get the AI to do the bulk of the heavy lifting, it just makes it much easier then for, for the humans that need to come and check that as well.
I guess as far as standards go and compliance, I'm not in tune enough to what's out there. There might be something from NERC or OGC or something, but I think it would be great if there was a standard format that everybody agreed on, and then they could deviate from that for their own needs. But then there was one repository where it all sits. That's not been the case from what I've seen. It's very specific from utility to utility and what they need and what that different division. And I'm seeing a lot of different platforms for storing and disseminating being used by a single utility at one time while they're trying to figure out what they like the best.
Yeah, and that's true. So even in the NERC standards around the requirements for vegetation analysis, they kind of have 6 requirements. And some of those are kind of core, safety, stuff. Others are performance-based as well. And so there's kind of a minimum standard that the operators' networks need to stick to. And then there's more that could be done on top as well. So it is a little bit fragmented. Different companies will be doing sort of different things as well. And they all seem to have, their own processes. Some of it are quite similar. There's clearly overlap. But yes, there isn't necessarily this kind of, overarching standard at the moment that everybody's adopting.
I wanted to ask Dennis, I'm sorry.
I was just going to say that fragmentation here, that was really kind of what I was driving at there. In taking that back, thinking about that in the context of the information sharing, is there opportunity from, I guess this is opinion based, right? So this is not that it was official answer, but from an opinion perspective, is there opportunity across the industry to really open a dialogue around that fragmentation to improve a data sharing opportunity, or is it really what's the opportunity there? Is there an opportunity there from an opinion base for the group?
Do you mean from sort of one company to another company, or one region to another region, or within the company itself?
Yeah, I guess from all aspects, right? There's opportunity from division to division, right, within a company. From a regional perspective, the larger the data set, the more information around a region. And then across the board, Ron mentioned, there's security, there's other issues that need to be bridged there. But if there's a fragmented collection system going on right now, I guess even if you can bridge the security gaps, it sounds like the access to that data might be limited because it's being addressed in different perspectives. And it isn't an apple to apple comparison, if you will. Is that a fair statement, and any thoughts around that?
I think so. I mean, I think the immediate one, and I think, Hayden and Larry did speak to this, but within the organizations themselves, there isn't as much sharing across the board, across different departments that may need the same kind of data. And so you kind of get these individual orders, which could, all come into one. If you had like a total specification, you'd probably be able to address all of them and do that in a more cost-effective way and give access as well. So definitely we see that. We see the same kind of thing actually happening, not in utilities, interestingly, in cities. We do a lot of city mapping, and then across city departments and across different companies, we now start to see that, that they're interested in kind of co-funding and co-sharing of this data. From utility company to utility company, I haven't yet seen it, but that doesn't mean it doesn't exist. I don't know if any of the other panelists have more of a view on that one.
I do know this, at least in Arizona, we have AGIC, which has an initiative to share, LiDAR data, to share ortho imagery, things that are captured that people are willing, state-owned data is state-owned data and therefore is generally shared pretty publicly. So there are data sets that are out there that, hopefully it will become less fragmented, that would be usable. It really comes down to how does the public-private partnerships evolve to the level where there's a willingness to share this kind of data. And you look at the smaller co-ops in our state, and to have access to this additional information would be another tool that they could use now to help manage their systems, because they're not going to have the kind of funding that a larger utility might have.
The other thing, and it's a great point actually, Larry. The other thing, and Ron, maybe to get your perspective on this, but there are certain organizations as well. I mean, obviously there's the 3DEP program, albeit that the resolution of that data, it's not granular enough really yet to use that. There can be some advantages actually, you could use certain points for corrections. But organizations like the Earth Archive, which is starting to do some mapping as well, it's an open source data set they're creating. It doesn't replace it, but maybe that could be used as some ancillary data. It might have some value, in terms of looking at that. And I know, obviously, Ron, you've worked very closely there as well.
No, I think that not only using data within the organization, say between the engineering group and the veg group and the roads group, we should look beyond just the utility that, say, has commissioned the work initially, and look at every other potential stakeholder in that area. If it's a transmission corridor, through the forest or through the desert, there may be minimal other stakeholders that would be interested, but we're doing a lot more distribution, and we're flying it as a wide area. So we might be picking up 10, 20, 30 square miles at a time. And it's typically, distribution is going to be overpopulated neighborhoods. So now we have, 50 plus point data that could be used by the municipality, by the individual homeowners for planning solar on rooftops, microgrids, augmenting, Peter, what you might be collecting from the ground. So I think, how do we extend the value of that, not just to the utility, but to other groups that might be interested in that information, so that, if we can bring the cost down of acquisition, add in the secret sauce that you're creating for AI, I think the overall product becomes much more accessible for a much greater number of people. I mean, I guess we're all going to get to the point of we're just going to use this thing to scan, our houses and our backyards, but crowdsourcing can be part of it too. Tie that in with what Larry and Hayden can do on ground control, and we have an incredible product for the future, and I don't think it's that far away.
Agreed. Yeah.
Outstanding. I appreciate that perspective. So then, Annie, if you could share that poll with us, I'd be curious to get to that. So, interesting that the LiDAR, and I believe everybody can see this poll result. I'm hoping, Anne, is that correct? Everybody can see the results there?
Yes.
Mm-hmm. Yeah.
All right. Yeah. So, how often is LiDAR captured? We've got almost 60% of the audience is they're never capturing it. And then we've got a group that's in that every year position, and then they'll kind of trickle through the rest of that. So, and the question specifically was, how often do you capture LiDAR for inspections? So it looks like there's an opportunity in this area with folks that are, and then there's a large group that's capturing it annually, which I think from the Voxelmaps position and what you described in that fourth dimension of time really provides us some opportunities in there. As we kind of approach on the last piece of this, and we get toward the end, Ron brought it up, and it was one of the questions I had in an earlier group to talk about, was around the some of these bring your own, I'll call it a bring your own device, I'll butcher it, but we're seeing technology. Ron brought up his phone. Some phones now have LiDAR sensors on there. How far off into the future is it before we can start to have access or opportunity where crowdsourcing of data can get added into other sources and filters are added or layers are added so you know where it came from, as far as maybe what the quality is or the quantity is for your, depending on what your analytic is. How far away are we from adding other sources into the professional sources you have available to augment what we're doing and drive some of those price points?
I can give an opinion on that, actually. So years ago, my previous business, actually NavMii, the one where Voxelmaps spun out, back in 2007, we were the first mapping and navigation company to work with OpenStreetMap. If you know, OpenStreetMap is a huge crowdsourced entity. So two friends of mine back in London, when I was living in London, set that up, and we worked together on building that out. And in the beginning, everybody laughed at the idea, why would people want to go and map? It's never going to take on. And actually, it's the biggest mapping project in the world in terms of the number of people that now contribute to that data set. So it's possible. I think two things are holding back at the moment, but they're probably going to progress very quickly. One is the sensors on the phones. They're nowhere near the quality of, obviously, the sensors used for mapping at the moment, both in terms of noise, range, and accuracy. That's one kind of limiting factor. But that will start to get addressed. Maybe it's not going to really replace the LiDARs that obviously Ron's using from the sky, but it will have its place. I think the second point, though, is where is that likely to be deployed? And I think what we see, a clear-cut way that people will be mapping their own spaces, crowdsourcing their own spaces. And that will be their homes, their yards, things around them. They'll probably do that pretty quickly. Whether we could convince them to go and do some of this kind of collect, and you've got to think about the safety angles as well. There might be some problems here. But I can imagine there might be models which would incentivize the crowd to go and do more commercial forms of collection. So I think it's something that could materialize. It won't replace everything that everybody's doing, certainly, but it could be an additional data source for certain use cases.
I can see where if a homeowner were looking at their trees and had a sensor that was accurate enough to give good data and getting some information that's maybe outside of what's being captured by a utility or by a transportation entity, but potentially could affect their infrastructure if it were to go that direction. It might be interesting to be able to access that if folks are really doing that now. So appreciate that perspective. I'll pause there for a second in case anybody else might have perspective to add to that as well.
Yeah, I guess I think if you could tell a homeowner if they go and take pictures of the poles that are running through their backyard or something, they get a discount. It's ancillary data. It's not spatially 3D accurate, but there should be some value to that, to just have a snapshot in time of what that backyard looks like and what's going on with that pole.
Great idea. Yeah.
Yeah. Yeah, I think to add to that, let's just start with what we know. Everyone takes a picture with their phone, so let's start with pictures, and then we add the next layer of information. Whether they're using an app to georeference where that image is taken, and then progress to LiDAR. And Hayden, I love that idea. A buck off if you send us a picture of the pole in your yard.
Outstanding. Well, I'm going to want to thank everybody for their time and their information here. Not going to completely let you off the hook yet, because as I turn it over to Joe, he said he may have a question for the group. I'm not sure if it's been answered at this point or not for him, but I want to give him the opportunity before we run out of time. If you did have something, Joe, that you want to put before the panel. But again, thank you, everybody. I appreciate the opportunity to have met everyone and work with you here today. And look forward to future opportunities.
Thank you.
Thanks, Dennis.
Great work, everybody. Thank you, Dennis, and thank you, panel. We have a couple of minutes, so let me ask this question that popped up during Larry's talk, actually, but some of the rest of you use this technology. Is there published research on the accuracy of GNSS used under or near high tension lines?
So the long and short of it is, I'm not aware of that. I mean, in general, GNSS receivers have challenges as they get near metallic objects. So part of the emphasis on the offset measurement is get away from trees, get away from metallic objects, or anything that's a reflective surface, because essentially you're creating multipath and that confuses the GNSS receiver. So would I suggest you want to record underneath a pole or a high tension line? Probably not. If you're in the middle of one and it's going over your head, in all honesty, it's not going to have an effect on the receiver to any significant degree. It's really creating that environment of pristineness. You know, can I see the satellite that's in the sky, imagining a cone above my head, clear line of sight without it reflecting off of something or being obscured by something.
Similarly, what about influences created by the magnetic field of a power line when you are using a compass to determine the direction of your laser shot?
So that would be an issue. If the magnetic fields are significant enough, there's a possibility that could skew your compass. And what that requires you to do is, make a determination. One, am I being influenced by magnetic fields, which is pretty easy to detect. I mean, even the most basic of compass could go figure that out. Primarily, we suggest everybody calibrate their compass anyway when it goes out into the field. The compass that would be, integrated with a laser rangefinder. It's good hygiene, for lack of a better term. The compasses do drift a little bit, and the environment that you place the laser rangefinder itself can be very sensitive just to localized. I learned myself by just holding a pen in my hand when I was trying to annotate something, how much it affected the compass. So there is a little bit of learning involved in the hygiene that you want to use with a laser offset, especially one with an integrated compass, because it will be susceptible to magnetic fields.
Thank you. Well, we need to move on to Sven, but I do want to also point out something that wasn't discussed, and it first popped into my head when Ron was showing his moving power line. But really, it also occurred to me when Peter was talking with this giant voxel holding the Earth, and that has to do with this business of datums and projections and how we apply them to our data so that we can actually overlay stuff. If we get to crowdsourcing, it'll definitely be a problem, but I think it's even a problem among commercial providers of different types of data, even coming from the same provider sometimes, just because they are so dependent on the manufacturer's understanding of this particular issue. You don't have to comment if you don't want to. I'm going to move on to Sven, who is our next speaker.